All right, so continuing in chapter 11, we're now looking at the spinal cord. This is slides 45 through 59. So the spinal cord is still part of the central nervous system, and it's going to be the connection basically between the body and the brain. Um, and most of this information should be just general knowledge. It extends down through the vertebral canal. It begins at the foramen magnum. Again, once the brain stem exits the cranial cavity, it is then called the spinal cord. And it actually doesn't go all the way down to the low back. It terminates about the level of L1, L2. We'll talk about the fact that it's got 31 segments, which each segment gives rise to a pair of spinal nerves. So we have 31 pair of spinal nerves. The spinal nerves are grouped according to the level of the vertebrae they're associated with. So we'll look at how they are named. Within each group, the pairs are numbered in sequence from superior to inferior. So for instance, in the cervical spine, C1, C2, C3, we're going to have nerves that come out between those bones, and they get named accordingly. So as it goes through, we'll see how that works. There are some parts to understand. We have two enlargements, one called a cervical and one called a lumbar enlargement. This is where the nerves coming in from the arms and the legs, as they merge into traffic, there's going to be a little enlargement there. So it's called the cervical enlargement and the lumbar enlargement. Towards the bottom, there's going to be like a dull little cone, and it's called the conus medullaris. That is, again, you'll see it right here. That's basically the end of the spinal cord, the conus medullaris. Then there's going to be, we're going to look at this in just a second, but if I was to draw this out on this side here in the conus medullaris, where it stops, there's going to be a lot of nerves that come off of here. We're going to look at this in the next slide that is called the cauda equina, which literally means tail, the horse's tail, right? Because it looks like this. But in all of that, there's one special tail that comes straight down. It is an extension, actually, of the pia mater, and it is called the filum terminale, or the final, or the terminal filament. It is basically like, those little, if I have a little screen, the little white screen that I pull down, it's got the little cord here, and for me, you probably always see it, I always like that screen up, and I'll have the little cord wrapped up here so it doesn't get down. That's kind of like the filum terminale. It's a little filament that's going to anchor the spinal column to that little coccyx, the little bottom part of the sacrum. And then finally, again, I talked about this just a second ago, the cauda equina, which literally, again, means horse's tail. And it's just the way it looks here at the bottom, the way the nerves branch off that conus medullaris. Now, the spinal cord is going to have a very unique look to it. You can kind of see this gray matter. It looks like, it's always called, look like a butterfly, and then white matter's around the outside. In the gray matter, in lab, you've looked at, the horns, the anterior and posterior horns. There's a canal in the center, and it's called the central canal. So we're going to look a little bit at this, but not like you did in lab. The spinal cord is the center for spinal reflexes. You're going to have things come in, get analyzed, and go out without having to go to the brain, but there's also the pathway for those impulses to go to the brain to get analyzed. So we're going to look at reflexes here. Reflexes are fairly straightforward. There's kind of a pattern all the way. If I went all the way back to chapter 1, we talked about you're going to have a stimulus that goes to a control center, and the control center is going to put forth something to correct it called an effector. So it's the same thing. We have a receptor, We're going to say these receptors are out in the world feeling for things, and if something is noticed, it's going to send a signal in on an afferent neuron. That afferent or incoming neuron goes to the central nervous system, either the brain or the spinal cord, where there's going to be some decision made on it. And if the decision has something that needs to be, or if that receptor in the sensory neuron is bringing something that needs to be acted on, it'll go out on a motor or efferent neuron to a muscle or gland, and those are called effectors. That's a simple reflex arc. Actually, this one isn't. We'll look at a true simple reflex arc, only has sensory and motor, but the very generic ones have a special neuron that's going to be in the central nervous system. Which is the most common, as it says here. That special one is called an interneuron. They're the ones that kind of do the thinking, decide what's going on. So this is the one, you should have looked at this at lab again. There's 5 parts to it. You have a receptor up here. So let's say I've got this little mosquito that lands on me. I don't know if that looks like a mosquito, but whatever. It's a little mosquito. The receptor is going to feel it. It's going to send a signal in on this sensory or afferent neuron. It's going to go all the way in. It's going to pass the little dorsal root ganglion there, and it's going to go all the way in, drop its information. This is a synapse on a special neuron called an interneuron. The interneuron is the only one of these that is considered a central nervous system portion. So this interneuron is going to decide what's going on. It's going to kind of analyze it, say, all right, as we had this happen before, what did I do? To before when it happened? Did I like it? Did I not like it? Do I want to change it? Do I want to do the same thing? All those go through this little interneuron. When something decides to be done, it's going to synapse with a motor neuron. Now it's going to go out. That motor neuron can also be called an efferent neuron, and that will go and drop off its information on an effector, which is usually a muscle or a gland. This is a little breakdown of all of that, and it gives you a little idea of what's going on. So this is that one that was a really simple reflex, and they call it a monosynaptic. Mono meaning one, synapse is a synapse where the neurons talk. So we've got an incoming neuron, a sensory neuron. It drops off its information directly onto a motor neuron. There is no interneuron in this one. So there's only one synapse. This is what if you've ever been to the doctor and they do the little patella reflex where they whack your knee with the little rubber hammer, they're looking for what's called a stretch reflex. And just think about this. So I've got this muscle here, and this is my quadriceps, all right? As it goes through the patella, and it's going to be attached to my tibia. If I relax, there's going to be a certain amount of pressure here. When they hit that patella with the hammer, there's a quick stretch, and your body is going to analyze it as something has grabbed your leg and pulled it. And so I'm going to have a very quick sensory neuron come in, and since if something's pulling at my leg, the first thing I want to do is kick at it. There doesn't have to be any decision to be made. So I have one synapse. It goes right back out on a motor neuron. It's going to cause that same muscle that has felt the stretch to resist and to tighten up. And that's going to cause my leg to kick out. And that is a monosynaptic or stretch reflex. Now the next two are grouped together, and it's kind of, I want to make it as simple as I can, right? This is called a withdrawal reflex. This is simply meaning something I've either touched or stepped on something that I don't like, and I'm pulling back. And so, this one has it, you're stepping on a tack. I personally think that the biggest obstacle, the biggest thing, if you've got kids and you've ever stepped on one of these things called a Lego, man, that is not cool. Right? I wish Legos were made out of like Nerf or something and rounded instead of sharp and pointed. But anyway, if you've ever stepped on something like that, as soon as you feel it, you're going to have receptors. They're going to send a signal in. Now think about it. The name is withdraw. I'm trying to pull that foot back from what I'm stepping on. So I'm going to have a sensory neuron that goes in. It's going to have an interneuron that's going to analyze it. it will send a signal out to the muscles that are designed to pull that part of my body away. It could be that I'm grabbing something hot and I'm trying to pull it away. So that's how that works. It's a withdrawal reflex. Now, along with the withdrawal reflex, there is also what's called a cross extensor reflex, and it works together. So we're going to go back to this stepping on a tack or a Lego. I'm pulling my leg up. Now, if that was all that happened was the withdrawal reflex, man, I would fall, right? Because I'd pull my leg up, but if I'm stepping on that, that means that I'm getting ready to put my weight on. If I pull it back up, I've got to do something to balance myself, and that's what this is. During the withdrawal reflex, the flexors of the affected side contract, which is pulling my leg back, and the extensors are inhibited. But now I need to have the extensors that are on the opposite side, crossed extensor, all right, contract, and that's going to cause my body weight to shift so I don't fall. All right, now on with this, there's another one. There's another reflex called the "oh my gosh, did anybody see me" reflex. So as soon as this happens, you have this reflex where you look around to see if anybody saw you. And I hope you're laughing at that, because it is true. You look around to make sure that if something happens like that, nobody saw you. So anyway, I'm just trying to provide a little humor in there. So anyway, so as we go through, we're going to look now at tracts in the spinal cord. And now this always gets people at first to give them a little heartburn because they get really worried about this. And you see all these and it sounds so crazy. But it's very simple, all right? So my brain up here in my head, right? This is the boss, right? The brain is controlling things. Now I've got the spinal cord down here, and then I have my arms and my legs getting signals off my spinal cord, from my spinal cord, right? So this is my little spinal cord. So ascending tracts. Think about this. If something is going up the spinal cord to my brain, it hasn't been analyzed yet. So it is a sensory input. Always. Anything going up means that it's bringing information into the brain, which means it's sensory. And with that, it should be easy to understand that descending, anything that is going down, means that it is leaving the brain and it is going down to wherever it needs to go. So all descending tracts are motor. And that's an important thing to remember. So ascending tracts are always sensory, descending tracts are always motor. Now, outside of this little part here, which I want to talk about at the end, all of these other ones are easy to see if they are ascending or descending. And it all goes to the fact that they all have spine or spinal in the name. If it is in the first part of the name, spinocerebellar, this is an ascending tract because it's going from the spine to the cerebellum. So it's ascending. So this is sensory. Now this one is corticospinal, right? So it's going from the cortex down to the spine. So if the word ends with spinal, it is motor. And pretty much every one of them do that. Spinal's at the end, so it's motor. Spinal's at the end, so it's motor. Spinal's at the front, so it is sensory. Spinal's at the front, so it's sensory. Spinal's at the front, so it's sensory. Spinal's at the back, so it's motor. Spinal's at the back, so it's motor. All you have to do is look and find where the word spine is in the name. If it's at the front, that means it's going from the spine to the brain, which means it's ascending and thus sensory. If it ends with spine, that means it's going from the brain down to the spine, which means it's descending, making it a motor tract. The only ones that are different are these at the back. Now, both of them are sensory. And now the only one I'm going to hold you accountable for is this one. And you should recognize this name, cutaneous. Cutaneous is the skin. Remember, the cutaneous membrane is the epidermis and dermis, which is scientifically the skin. It's the largest organ in the body, and it has a ton of sensory receptors in it. And so the fasciculus cutatus is all about feeling from the skin. All right. So hopefully that makes sense. I'm not worried about this. I'm not going to get into these specific ones, how it goes up or how it goes down. So this gives a list of the different tracts, whether they're ascending or descending. I'm not going to ask about, any of this where, specific stuff where it's going. It will basically just be if it's ascending or descending.